523 623.
We rolling, we live. Okay, looks like we are live and we are good and we're streaming. Sounds good. Hello everyone. Welcome to the OneClass channel. My name is Millen Wang and I am a third-year software engineering student at the University of Carleton. Today I'll be going over some commonly asked mathematics questions at both the high school and university or college level. If you need some help tutoring, check out the links in the description below. Okay, sounds great. So let's switch over to my screen and we can start doing some mathematic magic. Alright, so this is the first question that we're going to handle. The first question is, what is the integration of 1 divided by x? So to draw this out formally, I'll draw out, we are looking for the integration. Whoops, let me get my pencil tool. We are looking for the integration of 1 divided by x dx. Okay, so we know that this is equivalent to the integral of x to the -1 dx. And we know that the reciprocal is the same as raising something to the power of -1. Now normally we would do, we'd add 1 to the power and then have a coefficient in the front. But x to the power of -1 is a very special case where the derivative of this is equal to the natural logarithm of x, the absolute value of x, plus a constant of integration. Now it's always important to have our constant of integration because let's say we want to take the integral again. If we don't have that constant, we're going to be in trouble. So we definitely need that constant here. Now we know that we can check our work of our integration by seeing, hey, if the derivative is the same as the original, we're probably good. So let's do our double check. And we will do the derivative of natural logarithm of the absolute value of x plus c. So we'll do that by doing d over dx over this whole thing in brackets. So we have natural logarithm of the absolute value of x. I suppose in this particular case, the absolute value being on the inside or outside does not particularly matter. Plus c. So we know that by definition, the derivative of natural logarithm is 1 divided by what's inside, and then multiply that by the derivative of what's inside through the chain rule. So let's do that. So we have 1, these are equal to each other, so 1 over x multiplied by the derivative of x, which is like d over dx of x. That cancels out to 1, plus the derivative of c is 0. So this is just equal to 1 over x, because here we have 1. So we don't got to worry about that. And our result, after we took the derivative of our integration, we found that we have the same as our original, 1 divided by x. We know that the answer to the integral of 1 divided by x is definitely natural logarithm of x plus the constant, because we can never forget the constant when we're doing integrations. Now, why do we need the natural logarithm here, or the absolute value in the natural logarithm? Well, I'll scroll down here. Let's say we want to draw the graph of a natural logarithm. So we got our y-axis vertically, and we have our x-axis horizontally. I'll get a different color for this. Let's say red. The logarithm has a shape like this. And where it intersects at y equals 0, that is x equals 1. Because of this, and because the natural logarithm never is invalid for a negative x, like try taking the natural logarithm of like -5. It's not going to work out. So that's why we need the natural logarithm to have an absolute value on the inside, so that we can never get a situation where we're taking the natural logarithm of something on the negative side. Always hit it with the absolute value beforehand. So in our answer that we have here on OneNote, it's all looking that way. We do have the right answer, and we can verify the solution. So that's looking great. Let's leave a comment there.